So, have you ever thought about the invisible digital safety net that keeps, global shipping from just turning into a chaotic demolition derby?
Yeah, I mean, it's really one of those critical layers of infrastructure you probably never consider. But
Yeah.
if you look at a live map of global maritime traffic, the oceans are just absolutely saturated.
Right, like totally packed.
Exactly. You have thousands of massive vessels carrying millions of tons of cargo, and they're all navigating through narrow straits, severe weather, and, pitch black conditions.
Wow.
So without a reliable, universal way to see each other's data, the sheer volume of traffic would result in absolute gridlock. Or worse, constant collisions.
Yeah, that invisible net is called AIS, the Automatic Identification System. And if
Mm,
you've ever stood on a ship's bridge or, even just tracked a package coming from overseas,
mm.
AIS is the absolute bedrock of modern maritime safety.
It really is.
It's the system that ensures vessels actually know who is around them. But the overarching theme of the sources you shared with us today is that this bedrock is, well, it's showing massive, undeniable cracks.
Yeah, big ones. The entire system is buckling under the pressure of modern data demands. I mean, the maritime industry is facing a severe infrastructure bottleneck right now.
Right, because modern ships are essentially floating data centers at this point.
Exactly. And the industry is attempting to push the future of high-density navigation through a communication pipe that was engineered, well, decades ago. And it was built for simple text bursts.
Which is wild to think about. So today's deep dive takes a really fascinating stack of sources you've provided, including technical schematics, bridge equipment diagrams, an incredibly insightful analysis from Master Mariner, and expert system breakdowns. And we're going to use all of this to explore the industry's radical fix.
Right, which is an entirely new architecture called VDES. That stands for the VHF Data Exchange System.
And the scoop of this upgrade is massive, right?
Oh, it's huge. We are looking at a complete evolution of how ships communicate with the world. They're moving from a system of localized radio beacons to a globally integrated high-speed network.
So we're going to unpack how global shipping is making this massive leap from like the equivalent of dial-up internet to global broadband.
Yeah, that's a great way to look at it.
We'll look at the incredible new capabilities this unlocks on the bridge, but more importantly, we will explore the surprising, almost counterintuitive dangers this digital superhighway brings to the human beings actually steering the ships.
Because, solving a technological limitation very often creates a psychological one.
Mhm.
And the bridge of a modern cargo ship is the perfect petri dish for that exact phenomenon.
Totally. But before we can really understand the mechanics of this new VDES architecture, we need to establish why the old system is failing so spectacularly.
Right, we have to look at the foundation.
Yeah. And the foundational issue comes down to the physical limitations of the radio waves themselves.
Let's look at legacy AIS. I mean, it's an incredibly resilient system, but fundamentally it's very basic. It was engineered to do one primary thing, which is broadcast, simple identification, and position reports.
Just the basics.
Exactly. A ship transmits a tiny data packet, basically saying, here is who I am, here is my heading, and here is my speed. And it does this over two very narrow 25 kilohertz VHF channels.
Right. Known as AIS 1 and AIS 2. And the key word in that schematic is definitely narrow.
Very narrow. The modulation technique it uses is called GMSK, or Gaussian minimum shift keying. Now, GMSK is brilliant for marine environments because it is incredibly robust against interference.
Like from high seas or bad weather.
Exactly.
Hmm.
But the trade-off for that ruggedness is that it is agonizingly slow. I mean, it maxes out at a data rate of just 9.6 kilobits per second.
Wait, 9.6. At 9.6 kilobits, you're operating at practically telegraph speeds by today's standards.
Yeah, it's tiny, which,
Yeah.
is perfectly adequate when all a ship needed to transmit was a tiny string of text coordinates every few seconds. But the entire maritime industry is aggressively shifting towards something called e-navigation. We aren't just sending text blips anymore.
No, not at all. The modern bridge requires a continuous exchange of high-density operational data. We're talking about the need to download dynamic ice charts, multi-layered weather polygons, and complex digital route plans in real time.
And the physics of standard AIS simply cannot support those massive data payloads. You cannot physically force a high-resolution ice chart through a system built for tiny, intermittent text coordinates.
Just won't fit.
It won't. And when ships attempt to do this in busy shipping lanes, those two critical safety channels get completely clogged.
Wow, so the safety net itself gets compromised.
Exactly. The baseline collision avoidance messages end up delayed or dropped entirely because the bandwidth is choked with all this other data.
So, trying to run modern shipping data over legacy AIS is basically like trying to stream a 4K movie over a 1990s dial-up modem while someone else in your house is trying to use the landline for an emergency call. The whole system just gridlocks.
That is the perfect analogy. And the data congestion is really only half the problem. The other half is geographic.
Oh, right. Because of the radio waves?
Yeah, because standard VHF radio is strictly line of sight. The deep ocean has traditionally been a total data blackout zone.
So, once you're past the horizon, you're cut off.
Right. Once a vessel travels beyond the reach of coastal radio towers, it loses that two-way data exchange entirely.
So, the industry has a system that is basically choking on data near the coast and is completely deaf out in the deep ocean.
Exactly, which is a terrifying combination.
Yeah, really. So that brings us to the multi-million-dollar fix VDES. And from the sources, it looks like to solve this 4K over dial-up problem, the industry didn't just scrap the old system.
No, they couldn't risk it.
Right. The schematics show they essentially built a multi-lane superhighway right around it.
Yeah, VDES is essentially AIS 2.0. The brilliance of the architecture is that it integrates legacy AIS rather than replacing it.
So the old stuff still works.
Exactly. Those critical collision avoidance broadcasts, the basic "here I am" safety signals, they still retain the absolute highest priority in the spectrum. The fundamental safety net remains untouched.
And they achieve this by completely separating the traffic into three distinct modules, right? Part one is that legacy AIS, which is strictly for safety.
Right.
Then part two introduces new dedicated channels called ASM, or application-specific messages.
Yeah, and the ASM channels basically act as express lanes for basic text and simple hydrographic info. It pulls all that non-critical clutter off the main safety channels.
So by clearing the clutter, the safety signals finally have room to breathe.
Exactly.
Yeah.
But the real game changer in the schematic is part 3, VDE, or VHF Data Exchange. This is the new high-speed broadband pipeline.
Looking at the radio physics involved here, the leap in capacity is staggering. They build this superhighway on standard VHF radio frequencies by fundamentally altering the waveform and mathematically expanding the lanes.
Yeah, it's pretty wild. VDE completely discards that slow GMSK modulation. Instead, it utilizes advanced modulations like 16 QAM or quadrature amplitude modulation.
Okay, 16 QAM. Break that down for us.
Sure. So to understand the mechanism here, standard digital signals typically just turn on and off to represent ones and zeros, right?
Yeah.
But 16 QAM is much more sophisticated. It actively alters both the amplitude, which is the height of the wave, and the phase, the timing of the wave, simultaneously.
Oh, wow. So by altering the amplitude and phase at the exact same time, the system is stacking multiple bits onto the exact same wave.
Yes.
It's turning a single radio signal into a much denser packet of data.
The density increases exponentially. And then they pair that new waveform with wider lanes. The system mathematically and legally combines those standard 25 kilohertz channels into massive 50 or 100 kilohertz blocks dedicated entirely to VDE.
That's a huge jump.
It is. The end result is a 32-fold increase in data capacity. The data rate jumps from 9.6 kilobits per second all the way up to over 300 kilobits per second.
Okay, wait. I have to push back on the physics of this, though.
Sure, go ahead.
If you are suddenly blasting 32 times more data across these specific radio frequencies, aren't you just going to generate a massive increase in data packets colliding and corrupting each other in the airwaves? Like a 32-fold increase in traffic jams.
It's a great question, and the engineers actually anticipated that exact packet collision problem.
Oh, they did?
Yeah. To manage the chaos, the new system still strictly respects the legacy AIS structure, which uses a time division multiple access scheme.
TDMA.
Exactly. The system mathematically chops the radio frequency into 2,250 incredibly tiny synchronized time slots every single minute.
So that ensures every single ship and shore station gets an organized, specific turn to speak.
Right. And with the new 16 QAM modulation, the sheer volume of bits packed inside each of those individual time slots is vastly increased. But VDES also manages this traffic dynamically using forward error correction.
Which is what, exactly?
It's a mechanism that allows the receiving station to actively, mathematically correct errors in the data stream on the fly.
Oh, I see. It essentially fixes the typos in the data packet as it reads them without needing the sender to waste bandwidth retransmitting the whole message.
Precisely. And because of this structured error-free topology, ships aren't indiscriminately shouting into the void over an open radio channel anymore. They behave like discrete IP address nodes on a continuous network.
Wow.
Yeah. A vessel can securely ping a specific server onshore to download targeted weather data without ever cluttering the main broadcast frequencies.
That is so smart. And to solve that deep ocean black hole you mentioned earlier, VDES looks up, right?
Yes, exactly.
The architecture integrates terrestrial towers VDE-Ter with low Earth orbit satellite constellations VDE-S8.
Right. By combining those orbital relays with coastal towers, it creates a seamless global broadband node. So whether you are pulling into the port of Rotterdam or sitting in the dead center of the Pacific, you have high-speed data connectivity.
Which is incredible. But translating all this invisible radio math into the daily reality of the navigator, that is where the system truly shines in the sources.
Absolutely.
Historically, retrieving weather and safety information at sea was a massive cognitive load. Navigators relied on a system called Navitex to receive hazard warnings.
Yeah, Navtex. If you look at the old Navitex printouts in the sources, they literally look like telegrams from a century ago.
Yeah, they do. They arrived as these blocky, hard-to-read uppercase text strings.
Right. Imagine your daily workload as a navigator before this upgrade. You're standing on a pitching bridge in heavy weather. You have to pull a paper printout from the Navitex machine, read a list of raw latitude and longitude coordinates, walk over to your paper chart, and manually draw the hazard zone with a pencil and compass.
That sounds intense.
It is. It's time-consuming, deeply stressful, and leaves a massive margin for human error.
But VDES completely eliminates that manual plotting. Because the data arrives formatted in what the industry calls the standardized IHO S100 structure. This means the data is natively machine-readable. It bypasses the navigator's pencil entirely and renders instantly on the ship's primary electronic charts, the ECDIS.
Exactly. An incoming warning about an encroaching ice shelf no longer prints out as raw text. It instantly pops up on the ECDIS screen as a layered, dynamic ice edge polygon mapped perfectly against the ship's projected route.
That reduction in cognitive load is just staggering. And the capabilities expand far beyond weather overlays, right?
Oh, for sure.
This S100 data structure facilitates digital route exchange. The computers on different ships can securely exchange their intended waypoints over the VDES network in the background.
Yeah, and they can calculate complex interactions before the vessels are even in visual range of each other.
That's wild.
And ashore, port authorities can analyze the exact intended routes of dozens of vessels simultaneously. They can organize harbor traffic down to the minute to reduce emissions and wait times.
The emergency applications outlined in the expert breakdowns are just as critical. During search and rescue operations, the on-scene commander no longer has to dictate search coordinates over a crowded voice channel.
Right, which takes forever.
Yeah, instead they can digitally push live search grids and a common operating picture directly to the primary navigation screens of all the responding vessels.
And the bandwidth even supports live telemedicine.
Wait, really?
Yeah. If a crew member is critically injured mid-ocean, the ship can transfer high-resolution diagnostic images, detailed medical files, and live patient monitoring data instantly to surgical teams ashore.
That is literally life-saving. And for ship owners, the hardware integration is surprisingly elegant, too.
It is.
The new VDES transponders are designed to be fully backward compatible in form, fit, and function. So a technician can often just rip out the old AIS box, slide the new VDES unit into the exact same server rack, and reuse the vessel's existing VHF antennas.
Yeah, the hardware swap is relatively painless. But diving into the article from the Master Mariner you shared, Captain Raghu Sharma, we see a totally different kind of friction.
Yeah, this part was fascinating.
Because upgrading the machine essentially breaks something in the human brain. Captain Sharma points out a psychological trap that has been quietly growing in the maritime industry for years, something he calls procedural drift.
Right, and to understand procedural drift, you have to look at how crews actually behave on the bridge versus how the manuals say they should behave.
Exactly.
AIS was built purely for basic situational awareness. But because it placed a highly accurate, brightly colored target on the navigation screen, breach teams informally started using it as their primary decision support tool for collision avoidance.
Right, they started substituting AI data for the primary sensors. And you have to understand, the foundation of maritime safety is the call regs, the international rules of the road.
Right.
The call regs are fundamentally grounded in real-time visual observation and primary sensor data. A navigator is supposed to rely on looking out the window and using ARPA, their automatic radar plotting aid, which physically bounces microwaves off objects to prove they are really there.
But staring at a perfectly rendered digital target on an AIS screen requires far less mental effort than tuning a raw radar return.
It's just easier.
Yeah.
And Captain Sharma argues that VDES risks making this psychological trap exponentially worse.
How so?
Well, when beautiful, highly structured data, like a perfectly rendered ice polygon or an intricately calculated route from another ship, appears directly on your primary navigation screen, the human brain is hardwired to trust it.
Right. You naturally assume that because the data is visually pristine, it must be current, complete, and the absolute truth.
Yeah.
I mean, if you've ever stared so hard at the blue line on your car's GPS that you confidently almost drove straight into a lake, completely ignoring the giant body of water out your windshield, you know exactly how powerful this illusion is.
That's exactly it. Now scale that GPS illusion up to a 100,000-ton cargo ship carrying hazardous materials.
Yikes.
Right. The hyper-detailed information overlays constantly streaming in via VDES can distract the crew from the physical reality outside the bridge windows. The bridge becomes a saturated ecosystem of alarms, inputs, and digital overlays. More data absolutely does not equal more awareness if the human processing it is visually overwhelmed.
That makes total sense. And I found the second massive risk Captain Sharma identifies to be the most counterintuitive part of the whole analysis.
The cyber aspect.
Yeah.
Yeah.
Because VDES operates over standard VHF radio waves, there is a dangerous assumption out there that it is completely insulated from internet hackers.
Right. People think, oh, it's just radio, it's safe.
Exactly.
But that assumption fundamentally misunderstands how the hardware connects on the bridge.
Yeah.
A ship's ECDIS might be heavily protected by standard IT firewalls against, say, a bad USB drive or a compromised satellite internet connection. But VDES operates as a radio frequency sensor, not a standard IT network node.
Meaning the VDES antenna feeds its data directly into the navigation screens, entirely bypassing the ship's IT firewall.
Completely bypassing them. Legacy maritime systems are essentially hardwired to prioritize incoming radio telemetry as ground truth.
Wow.
They lack the standard authentication handshakes you would find in a modern IT network. They expect pure telemetry, not malicious code.
So the mechanism for an attack is terrifyingly simple. If a malicious actor compromises a shoreside network and broadcasts a corrupted VDES data packet, say, a fake hazard warning or manipulated ship route, the onboard ECDIS ingests it and renders it automatically. The hacker essentially has a direct, automated backdoor right to the captain's primary screens via radio waves, with zero human intervention required.
Yeah, it's chilling. And until global data authentication protocols are fully matured across the entire maritime network, that glaring vulnerability is sitting right there on the bridge console.
So, since the technology is clearly outpacing our ability to integrate it safely, the industry is being forced to rapidly rewrite how navigators actually do their jobs.
They have to.
The regulatory wheels are already turning at the International Maritime Organization. They are moving VDES into the formal regulatory pathway, specifically focusing on draft amendments to SOLAS Chapter 5, which governs the safety of navigation.
But the sources are really unified on this point. Regulatory implementation is lagging far behind technical capability. Simply bolting a new VDES box to the console does not make a ship safer.
Right.
Shipping companies must aggressively adapt their bridge procedures, guides, and safety management systems to mandate specific new protocols for handling this absolute flood of data.
And the sources outline 3 specific new protocols that crews must adopt. Number 1 is layer discipline.
Right. Layer discipline means strictly defining exactly what data is allowed on the ECDIS screen at what time.
Because it can get too cluttered.
Exactly. During high-stakes moments, like navigating a tight pilotage channel in heavy traffic, crews must be required to strip away non-critical data overlays so they aren't visually overwhelmed. You cannot allow a beautifully rendered weather polygon to obscure a critical physical radar target.
Makes sense. Number 2 is verification protocols. And this directly attacks the psychological trap of trusting the screen too much.
Yeah. Companies must force mandatory cross-checks into the daily routine. A navigator cannot initiate a maneuver to avoid another ship based solely on a VDES digital route exchange.
They have to check it themselves.
Exactly. They must verify that digital intent against their primary radar sensors and their own visual observation before ever touching the helm.
Trust the data, but verify with your own eyes and radar.
Exactly.
And finally, number 3, fallback drills.
And this is critical for maintaining baseline seamanship. Captains must routinely run drills where they literally turn the VDES network off.
Just flip the switch.
Yep. They have to force their crews to navigate the old-fashioned way. They need to maintain their core competence with manual radar plotting and visual bearings. If the network ever goes down or, a spoofing attack is suspected, the crew must be able to instantly revert to raw sensors without freezing.
So returning to Captain Sharma's ultimate conclusion technology expands a ship's capability, but it does not automatically grant safety.
No, it doesn't.
Safety depends entirely on how the bridge prioritizes and controls that information. The presence of a global broadband network is actively dangerous if the humans operating it lose their grip on the physical reality around them.
VDES is a monumental progression that solves a very real, very dangerous data bottleneck.
Yeah.
But it demands a significantly higher level of operational discipline from the crews utilizing it.
Well, we've explored how VES solves the dial-up bottleneck of legacy AIS, mathematically bending standard radio waves with complex modulations to catapult maritime communication into a high-speed, satellite-connected era.
And we've seen how it dramatically reduces the navigator's cognitive load, instantly rendering hazards on a screen, coordinating complex port traffic, and providing a lifeline during medical emergencies.
But we also uncovered the double-edged sword. The reality that flawless digital data can blind us to physical reality, and that direct radio links can bypass traditional cyber firewalls entirely.
It's a lot to manage.
Think about managing the notifications on your own smartphone. Having access to all the information in the world doesn't make you smarter or safer unless you know how to prioritize it, how to filter it, and, crucially, when to put the screen down and simply look out the window.
Maintaining that discipline is the ultimate test for the modern mariner.
Absolutely. I want to leave you with something to ponder long after this deep dive ends. As systems like VDES mature, they will inevitably enable ships' computers to seamlessly negotiate complex routes and collision avoidance with each other via algorithms operating in the background long before the human crews are even in visual range.
Which is coming sooner than we think.
If the machines are making the subtle, high-speed navigational deals over the digital superhighway, what happens to the traditional art of seafaring? Are we quietly witnessing the end of the independent, self-reliant ship's captain, replacing them instead with a human systems monitor for a global broadband network? Think about that the next time you see a massive cargo ship silently crossing the horizon, suspended in an invisible, crowded digital safety net.